Hi, welcome back to Case Study. Today's topic is minimum steps to a palindrome. Question: what is a palindrome? It is a word that reads the same forward or backward. Here are some examples. Our task is to write a function that takes in an incomplete palindrome and return the minimum number of letters needed to be added to the end to complete the palindrome. For words which are already palindromes, the function should return 0. The input is a partial palindrome as a string, and the output is a number as an integer. Here are some examples to show how the function works. Feel free to pause the video here and try to write the function on your own. Now let's solve the problem. How do we make a palindrome from a string? Let's take the word test as an example. At iteration 0, which is input, we have the word. At iteration 1, we make a copy of the first letter and paste to the end. Now we have test, which is not a palindrome, so we continue. At iteration 2, we make a copy of the first two letters, reverse the order, and paste to the end. Still, this is not a palindrome, so we continue again. After the same process, we have a word test, which is a palindrome, at iteration 3. So we stop here. The minimum number of letters needed to be added is 3. Now we can summarize this process. At iteration I, copy the first I letters, reverse the order, and paste them to the end. Repeat until a palindrome is observed. Return I. Now let's make the basic structure of our function. We are writing a function that takes a word as an input, and in the end, we are going to return I. So our objective is to determine I somewhere in the middle. Before we stop looping our iterations, we need a local function to check if the word is a palindrome or not. So we write a function called isPalindrome, which also takes in a word and returns false by default, and true when a certain condition is met. So what is the condition? The condition is the word reads the same forward or backward. So how do we write it? Here are some scripts that could be helpful. You can reverse a string by putting colon, -1 in a square bracket behind the string. So we can write the if condition in this way, and this function will be able to work as shown at the right-hand side. Furthermore, we can simplify the local function in this way. You don't have to say that return true when a certain condition is true and return false when it is false. You can just return the condition itself and it will tell you true or false. Now let's recall the looping iterations, and we are going to write the loop next. Firstly, we initialize I to be 0. Secondly, we initialize a variable called new word. It is a copy of the input word. Remember, we are trying to substitute multiple values into new word for the iterations. Now let's make a while loop. Question: when does the while loop stop? It stops when new word is a palindrome. So it loops as long as new word is not a palindrome. So we can write it in this way. This is an alternative. It may be more comprehensive based on our understanding. The while loop runs as long as new word is not a palindrome. Either way, we can move on to the iteration within the while loop. For each loop, we increase I by 1. That is the number of iterations we have processed. Then we need to redefine new word. Here are some scripts that could be helpful. You may observe that there is only one variable term in these 3 scripts, and we do have a variable for it. By replacing the digit with I, we can produce the same output by a single for loop. So, we can redefine new word in this way in each iteration. That's all what we need to write, and we are good to solve the problem. Now, let's think about this process again. Is it really efficient? The challenge asks us to find out the number of letters to be added to the end to complete the palindrome. So naturally, we will add letters until a palindrome is made. However, we can actually achieve our goal by deleting letters. Let's take a look at the alternative. At iteration I, delete the first I letters. Repeat until a palindrome is observed. Return I. In this example, the input word test is reduced to a single letter T, which is considered as a palindrome at iteration 3. It gives the same output. Now let's roll back to this point. We are going to define new word in another way. Here's some scripts that could be helpful. By replacing the digit with I, we can produce the same output by a single for loop. So, we can define new word in this way. We can also simplify the while loop. In this way, we drop the variable new word. Again, we can produce the same output as we did, but we wrote it in a bit simpler way. If we fully understand how these lines work, we can go minimalist. This is the minimum number of lines that I can think of to solve this problem. Now it's time for you to explore further. Execute these commands in your console. Can you conclude how the slicing works? This is case study. Thanks for watching.